Hello. Well, being an old guy, retired on a fixed income, I gotta save money where I can. And this machinery stuff can get astronomically expensive. And, I just gotta save money everywhere now. I'm just like a lot of people do. And I tell you, my excuse me, my pickup outside is a '89 Chevrolet with a 454 engine and a 30-gallon gas tank. And they're predicting here in Washington State $10 a gallon, and so I don't know. That's an interesting aspect. But things like that are going to make all kinds of stuff harder to get. And if you got a little machine shop, you can fix up your own stuff. I've got a I've got like a 1950 something Troy built rototiller out there that's still going. And I've been rototilling a little bit because it's starting to kind of clear up around here, but it's still quite cold. I'm here in the shop, but I'm kicking around these chucks, and if you look at the price of a new chuck, I'll show you something here. This is interesting. Now, on my video of tooling up that Axelson lathe, this is one of the items that was in there, and I put $300 on this. And this is a 12.5-inch Bison solid steel 3-jaw chuck. And I'm not kidding you, this thing weighs probably 140 pounds. It is just really heavy. But this is the chuck that came on that Axelson lathe. And it just doesn't really fit that lathe, It works on it, and I'm glad to get it, and I'm going to use it. But it just didn't look to me like it had really been on that lathe, It got stuck on there sometime. But these chucks here, they're almost $2,000. I think you can $1,700 or something like that, and I think that's without the back plate. And the back plate here is just absolutely massive. But the problem with this one here is it's really loose on the spindle. It slops around. And if you take the chuck off and put it back on, it doesn't repeat. Though the chuck does need a little bit of stuff like that, like the jaws reground. But so, before you grind the jaws, you got to get the chuck so it goes on consistently, and this don't. So if you grind the jaws, you take the chuck off and put it back on, it's still going to run out of true. So this is one of the basic things to do. And over here, now this is the chuck with the integral mount, a Cushman 3-jaw that I had in the jig bore. And I'm just checking it out here. And I actually got this, I don't have to, get so exact to be on a granite surface plate with this. But I got this old machine table all smooth enough that, I can gauge stuff, within thousands or half a thousands even. But this thing was kind of out of whack. You see it goes to 0 there. Just kind of checking it out like this, just almost 1/1000th of an inch. And I've got it better than a 1/2,000th or, a couple of tenths from this. But it's a lot better than it was. So I got this, parallel with the face of the chuck. And this one, I cut it back, and I tested it just with some marks from a Sharpie on there, and it's not contacting the spindle short taper evenly. And so I got to redo that. And I'm going to use the tree head for that taper. So I'll set this tree head, for the taper. I'll put it back over into the jig bore. Now I've got this is still set up here. And I moved the wall hopper head over to the horizontal mill because I want to test it over there. Let's see if I can get this stuff over here. Move back over. But what's neat about this is this machine's always parallel. I mean, it just doesn't move. And over here, I'm gonna I moved the wall hopper over here, and I just want to test it. And I tell you what, it takes a lot of time to trim that head. Hold on a second. And I think the best I could get that thing is half thousandths, something less than a thousandth. And the jig bore over here is a tenth. So it's I want to see what's going to happen. So I've got the back plate here for that bison chuck. And I'm going to put that in here and face it with the wall hopper head. I just kind of want to see what it'll do and see how accurate it will get this. Now, normally, see, you don't need this stuff to do what I'm doing here. I wanted to make that clear, that you can do this in a lathe, but it just takes longer to set up. And I think doing it in a lathe, setting it up in a lathe is going to be more accurate than like doing it in a standard milling machine. So that's kind of one thing I wanted to check out for myself. To see, compare this machine, running that wall hopper head, trimming it as good as I can to see how accurate I can get something, and we'll see, I can always face this if it does a good job, and it should, and then put this on the spindle, then cut this backside. I mean, this thing's heavy, just the back plate. I'm like, try to flip it over. Cut this face here that interfaces with this. And but inspecting this thing is highly accurate. It's just that it really slops on the spindle, worse than this other chuck. So I'm going to cut it back. I'm going to take the first cut here on this horizontal mill and then test it. But I'll most likely move it over to the jig boring machine, But this one's going to have to cut back just a little bit because it's so sloppy. There's another thing talking about doing these, and it was a tip pointed out to me, and neither one of these chucks have it, but they do it on a lot of more precision stuff, and I've replicated it. I've got a chuck around here that's it's on here. This is actually the same 8-inch 3-jaw chuck here, but it's just got the D13 back. They're a real common chuck. They put all kinds of direct mount backs on this type of chuck here. So one of the things that's kind of neat to do, and actually better, is give it an undercut here, a relief groove. And that way you can control the contact of this better than it just butting in and wearing itself against the shoulder, which is, this just works a lot better. And you can fit the chuck easier if you have that relief groove at the bottom of that. Thought I'd point that out. These mounts here I made because D13 mounts are kind of hard to find. But D16 mounts, like it's on the bigger chucks here, are more common than, you know. And the Monarch come with chucks, and they're fitted at the factory if you order a machine with chucks. And so when you gather, if you get a machine without chucks or you want to add chucks, you got to fit them to the spindle, or they're not going to repeat. And one of the things I like to do is to be able to remove a chuck and be able to put it back in with the work still in it. And I've run into that quite a bit, working on power sports, then doing work for like contractors and with excavators that broke down that you have to give a priority because there's people out of work. So if I have something power sport related in a lathe, I'll just pull it out and then do the most important work needs to be done. So I find that's why I like to do that. Okay, I'm gonna come back and we'll try cutting with the Wally in the jig board. I think that'll be kind of a fun thing to do. And I've been wanting to test this head in this machine anyway. So I'll be back. Bye.